dear students, welcome to IIT JEE NEET classes. This is Ashok, chemistry faculty. Today I am explaining most important named reactions for coming NEET exam. Actually, organic chemistry play a major role to get good rank in NEET examinations. In that particularly, named reactions play a major role, give good score in coming NEET examination. So all of you focus on named reactions in chapter wise. So today I am explaining some few named reactions on haloalkanes and haloarenes chapter. In coming NEET exam, our main target is to crack NEET with 150 plus marks in coming NEET examinations. That is our main target. So try to remember all the named reactions. I have been given some tricks to remember all the named reactions. I explained some named reactions right now. So just start the reactions. The named reactions are Groves process, Dargen's method, Finkelstein reaction, Schwartz reaction, Hunts-Decker reaction, Williamson's synthesis, Sandmeyer's reaction, Gutterman reaction, Balch-Schiemann reaction, and Dow's process, and Wood's reaction, Fittig reaction, and Woods-Fittig reaction. All these named reactions present in haloalkanes and haloarenes chapter. So now one by one all these named reactions I explained. In that first method is Groves process. In this Groves process, alcohols react with concentrated HCl in presence of ZnCl2 catalyst. We can get alkyl chloride and H2O molecule. Here concentrated HCl and ZnCl2 mixture is used for Groves process to convert alcohols into alkyl chlorides. Actually, concentrated HCl and ZnCl2 is also known as Lucas reagent. Lucas reagent. Actually, this Lucas reagent is used to identify different types of alcohols. Different types of alcohols. Different types of alcohols. In that, tertiary alcohol with Lucas reagent immediately gives turbidity. Turbidity. Tertiary alcohol with Lucas reagent immediately gives turbidity. Secondary alcohol with Lucas reagent gives turbidity after 5 to 10 minutes. 5 to 10 minutes turbidity is formed. Primary alcohol with Lucas reagent does not provide turbidity. No turbidity appears. No turbidity appears. So based on this, we can find which alcohols are more reactive, so that the alcohol react with concentrated HCl in presence of ZnCl2, we can get alkyl chloride. That reaction is Groves process. Here concentrated HCl react with a primary alcohol only in presence of ZnCl2 catalyst, but tertiary alcohol no need that much ZnCl2 catalyst, easy it can react, it gives turbidity immediately. So concentrated HCl and anhydrous ZnCl2 is called Lucas reagent. This Groves process is a nucleophilic substitution reaction. Nucleophilic substitution reaction. Nucleophilic substitution reaction. In this reaction, ZnCl2 acts as Lewis acid. ZnCl2 acts as Lewis acid. So anhydrous ZnCl2 cleaves the CO bond in alcohols, form alkyl chlorides in this process. Anhydrous ZnCl2 is used to cleave CO bond in alcohols. The next reaction is Dargen's method. In Dargen's method, alcohol react with thionyl chloride in presence of pyridine catalyst, we can get alkyl chloride and SO2 and HCl gases. So the obtained byproducts are easily escapable gases. That's why we can get pure alkyl halide in this method, in Darjan's method. So this is the best method to prepare alkyl chlorides. Alkyl bromides and alkyl iodides cannot be obtained by this method because SOBr2 is unstable and SOI2 do not exist. Only SOCl2 is available. So the alcohol react with thionyl chloride in presence of pyridine. We can get alkyl chlorides in good yield. So this is the best method to prepare pure alkyl halide because the obtained byproducts are easily escapable gases. Then we have only pure alkyl halide in this method. So by using Darjan's method, we can prepare only alkyl chlorides. Alkyl bromides and alkyl iodides cannot be prepared by using this method. The next reaction is halogen exchange methods. In that halogen exchange methods, one is Finkelstein reaction, another one is Schwarz reaction. In that number one, Finkelstein reaction. In Finkelstein reaction, we can prepare particularly alkyl iodides only. Alkyl iodides only prepared from Finkelstein reaction. So in this reaction, alkyl bromides or alkyl chlorides reacted with sodium iodide in presence of dry acetone. So this iodine replaces chlorine or bromine. We can get alkyl iodides. The obtaining byproducts are NABr or NaCl precipitates. Here the obtaining byproduct NABr is less soluble in acetone than NaI. So NABr get deposited in acetone. Due to this, the equilibrium will move forward reaction in this Finkelstein reaction. Due to equilibrium will move forward reaction, we can get more amount of alkyl iodide in this reaction. The next reaction is Schwarz reaction. In this reaction, particularly we can prepare alkyl fluorides from alkyl chlorides and alkyl bromides. In this method, the alkyl chlorides or alkyl bromides react with fluorinating agents like AgF or Hg2F2 or SbF3 or COF2. Any reagent. Alkyl chlorides and alkyl bromides react with any fluorinating reagent like silver fluoride and mercury fluoride and antimony fluoride and cobalt fluoride form alkyl fluorides. So in this reaction, chlorine and bromine is replaced by fluorine. So in this halogen exchange method, inorganic fluorides are used to get alkyl fluoride. So the byproducts are either AgBr or AgCl. So this is the best method to prepare alkyl fluorides from alkyl chlorides and alkyl bromides. This is known as Schwarz reaction. The next reaction is Huns-Decker reaction. In Huns-Decker reaction, silver salts of carboxylic acids reacted with bromine in presence of CCl4. We can get alkyl bromide and carbon dioxide, and the byproduct is AgBr. In this method, alkyl bromides we can get more yield compared to alkyl chlorides. This reaction follows free radical mechanism. free radical mechanism. So we can get mainly alkyl bromides in Hunsdiecker reaction. The yield of alkyl bromide is good yield compared to alkyl chlorides. Even in this method we can get primary alkyl halides are more yield than secondary alkyl halides than tertiary alkyl halides. So Hunsdiecker reaction is used to prepare primary alkyl halides, nothing but primary alkyl bromides in good yield. But in this reaction, when iodine react with silver salts of carboxylic acids, we can get esters, not alkyl halides. So 2 moles of silver salts of carboxylic acids react with iodine, we can get ester and carbon dioxide and silver iodide. So in this method we cannot get alkyl iodides. So this reaction is known as Birnbaum-Simonini reaction. Birnbaum-Simonini reaction. So in this reaction, silver salts of carboxylic acids reacted with iodine, we can get ester is the product. So Hunsdiecker reaction mainly is used for the preparation of alkyl bromides. And this reaction follows free radical mechanism. And in Hunsdiecker reaction mainly we can get primary alkyl halides in good yield compared to secondary and tertiary alkyl halides. And alkyl iodide also we cannot get through Hunsdiecker reaction, because silver salts of carboxylic acids reacted with iodine, we can get esters are the products. This reaction is known as Birnbaum-Simonini reaction. The next reaction is Williamson synthesis. In Williamson synthesis, alkyl halides like ethyl chloride and methyl chloride, whatever it may be, it is reacted with sodium ethoxide. We can get ethers. We can get ether, diethyl ether plus NaCl. In Williamson ether synthesis, alkyl halides reacted with sodium alkoxide. We can get ethers. So in this reaction, the alkyl halide is a simple alkyl halide and sodium alkoxide is bulky alkoxide. Then we can get ethers are the good products. So this is called Williamson ether synthesis. Williamson ether synthesis, simple alkyl halides can react with bulky sodium alkoxides. We can get ethers in good yield. For example, alkyl halides react with moist Ag2O, moist silver oxide, and dry silver oxide. What are the products are formed? In moist Ag2O, it becomes AgOH. So alkyl halide react with moist Ag2O, we can get alcohol and silver halide. And 2 moles of alkyl halide react with dry Ag2O, we can get ethers are the products. Ethers are the products. So alkyl halide, this is moist Ag2O, this is dry Ag2O. So we can differentiate easily. That is, alkyl halides react with moist Ag2O, we can get alcohols as the products. When alkyl halide react with dry Ag2O, we can get ethers. Ethers are the products. In moist Ag2O first react with water, we can get AgOH. This silver hydroxide react with alkyl halide, we can get alcohol. But in presence of dry Ag2O, we require 2 moles of alkyl halides, we can get ethers are the products. So dear students, in coming video I will explain some more important reactions from haloalkanes and haloarenes. So please subscribe my YouTube channel and click on the bell icon for daily JEE and NEET boosts to get good marks in coming NEET examinations. Thank you very much.